Reinforcing bar development length refers to the length of bar that needs to be embedded into the concrete to develop its full yield strength. Have you ever wondered why some bars terminate as a straight bar but some terminate as a hook shape? Well, this is to reduce the development length required, and a great example of this is the erection hooks in our anchor design, which I've drawn a diagram of. Another good example of development length is this. When we check our erection hook tensile capacity, we are assuming that the full 40 kSI strength of the steel bar is able to resist the forces imparted by the winch when hoisting the cables. The erection hook then transfers this force to the anchor, which we check for sliding and uplift to ensure it won't move during hoisting. Great. But we aren't done here. We skipped a step. How can we confirm that the steel bar isn't going to be able to achieve its full tensile strength without pulling out of the concrete anchor beam? That is where development length comes in. There are a lot of variables to describe development length, so I'll try to help you by going through an example of calculating the development length for the erection hooks in the anchor beam. While development length doesn't govern our suspended bridge designs often, it is an important skill and concept to understand in civil engineering. So Section 25.4 of ACI 318.14 details the requirements for the development of rebar. And first, we'll determine a few descriptors about our reinforcing bar. The most important pieces being that our bar in question is in tension and does it qualify as a standard hook. Because we are looking at the erection hooks with a 90-degree bend, we'll navigate back to Section 25.3 to ensure we have a standard 90-degree hook. Here, I'll put out a few important statements that we can verify. (25.3.1) asks you to conform to table 25.3.1, and we can answer yes to this as long as the rebar is bent according to the drawings. They should meet their 6 times the diameter of the bar minimum bend diameter. And the extension length should be at least 12 times the diameter of the bar, which is 7.5 inches for number 5 bar or 19.1 centimeters. And this helps explain the 20 centimeter tail that is suggested in the anchor details in the part describing the erection hooks. And I've drawn that here for you, as well as where we're worried about meeting our minimum bend diameter. And then Section 25.3.2 states that the standard hook must enclose the longitudinal reinforcement. And we can answer yes to that, because if you look at the detail, you see that the longitudinal reinforcement is enclosed in the hooks of the reinforcing bar. Now heading back to Section 25.4, we can calculate the actual development length. We skip over 25.4.2.3a because this is the equation we'd use for the standard bar in tension, but because we have a standard hook, we can continue onward to Section 25.4.3.1, where we see LDH is the greater of 6 inches, 8 times the diameter of the bar, in which a number 5 bar, 5/8 inch diameter, that's 5 inches, or this big equation here as condition A. So we'll dive into that equation, and you'll notice it looks a little overwhelming, but some of these variables we already know, such as Fy, the 40 KSI or 40,000 PSI yield strength of the rebar. Our lambda we know is 1 because it's normal weight concrete, and our F prime C is 1500 PSI or 1.5 megapascals. And our diameter of the bar is that 5/8 inches. So we really just need to find these variables, these psi values, in order to round out our equation. And note that a larger number for these psi values is more conservative. So if you are unsure about this, then choose the larger of the number of the two that you're considering, because this will increase the development length and mean you need a larger length to achieve full strength development. So in Section 25.4.3.2, we can take a value of 1 for our epoxy factor because there is no epoxy coating. We take a value of 1 for other the condition of other, and our cover factor because the hook extends out of the anchor and doesn't meet the greater than or equal to 2-inch cover on all sides requirement. And finally, we could take a value of 1 for our reinforcement factor because there is no confining reinforcement around all of the embedded bar. So plugging all these numbers in, we can get a value of approximately 33 centimeters. And using the smallest anchor as our example here, the length of the erection hook embedment is about 47 centimeters, which meets our requirements.